Okay, welcome to Calculus, Wednesday 408. Today we're going to do part 3 of derivatives of inverse trig functions. And let me get my pen going here. Okay. All right, what I'd like you to do is page 217 has a list of the derivatives of inverse trig functions. Now, we're not going to do every one of them. We're just going to do examples of some, but you'll find those formulas to use on 217 when you do some homework problems. I'll give you the ones you need for today. All right, what we're going to do to start off here, we're going to evaluate. I want you to notice closely f prime of 2 radical 3. So the derivative of some x value, all right, the x or some number, that would be an x value that you put into the derivative of this right here. All right, now this function, we got to find the derivative so that we can evaluate f prime, okay, of some unknown. Well, it's not unknown, it's 2 radical 3, but I'm just making the point that when you find the derivative of this, you're going to substitute this into it because that's what we're asked to evaluate. All right. So the first thing you're trying to determine is the derivative of this right here. If you can do that on your own, pause the video and work it on your own. But here's some things you might need, okay? The technical guide for finding the derivative of the inverse tangent. And you're also using the product rule. So pause the screen if you want to do it on your own. Okay, welcome back. Excuse me. Your answer should have been this down here, okay? The inverse tangent of x over 2 plus 2x over 4 plus x squared. Now, maybe you got something close to that, but just didn't simplify it. Always simplify it. That's just a rule of thumb you're going to have to accept, okay? It takes a little while to simplify sometimes, but that's what you got to do. Okay, we had the derivative, or we had the function x times the inverse tangent of x over 2, and we're going to find that derivative. Okay. And I'm going to keep my technical guide up there. All right, when you find this derivative, f prime of x, all right, you're doing a product. So the product rule says find the derivative of the first factor, which is the derivative of x, times it by the inverse tangent, or the second factor, of x over 2, add it to x times the derivative of the inverse tangent of x over 2. Well, the derivative of x is easy. That's just 1. So 1 times the inverse tangent of x over 2. Added to x times, now be careful on this, okay? The technical guide is throwing in the chain rule. When you do the inverse tangent derivative of an unknown, this is how it starts out. So it's 1 over 1 plus, and then it says x squared, but that x simply means the unknown. Your unknown is x over 2. So it's x over 2 squared. And then it's times by the derivative of the unknown. So times by the derivative of x over 2, and that's the chain rule. If you're getting tired of hearing me say this about the chain rule, good. That means you're starting to really learn it. It's no different than saying that g of x would be x over 2. F of x would be inverse tangent. Sorry, I didn't write inverse there. Inverse tangent of some unknown, so that fg of x would be inverse tangent of x over 2. So remember, method 2 is do the derivative of the whole thing times it by the derivative of the g part. That's what we just did. Okay, so we have inverse tangent here of x over 2 added to, all right, right here you have a 1 underneath that x. So that x is timesing by that 1 right there, so that's just x on top there. 1 multiplied by all of this down here is going to be 1 plus x squared over 4. Okay? x squared over 4. When you multiply x over 2 by x over 2, square the numerator, square the denominator. And then multiplied by 1/2. The derivative of x over 2, look, it's no different than doing the derivative of 1/2 times x. That's the same as x over 2. So bring the 1 down, you have 1/2, and x goes to the 0, so it's just having 1/2. Okay, all right, now be careful on this next part here. Inverse tangent of x over 2 added to, this 1 gets multiplied with that x right there, so that's just x. But this 2 gets multiplied by this down here, and that's 2 over 1 getting times by all of that. Okay, so let's change this, by the way. See that 1 I have right there? Let's make it 4 over 4 so that I have a common denominator. Now I have 4 plus x squared over 4 multiplied by a 2 over 1. Okay, a little more room here. Inverse tangent of x over 2 added to x over, by the way, can't I cancel that and make that a 2, right? When you're multiplying. All right, so you have 1 here by the 4 plus x squared over 2, and we're almost getting done here. That's just an arrow, all right? Inverse tangent of x over 2 added to, isn't it x divided by 4 plus x squared over 2, all right? This x is over all this down here on the bottom, so it's like a big division sign. And how do we divide fractions? We multiply by the reciprocal, so inverse tangent of x over 2 added to x over 1 multiplied by 2 over 4 plus x squared. And that's how we get our final answer at the top there of inverse tangent of x over 2 added to, straight across, 2x over 4 plus x squared. Now remember, that's what f prime of x equals. So if you put an x in its place, you can figure out, or you can evaluate a derivative, all right? All right, the same formula there is on the next page here. So there it is. The derivative of f of x is inverse tangent of x over 2 plus 2x over 4 plus x squared. I just want to see if I had that same answer. Okay, over 2x over 4 plus x squared. Okay, I did. All right, now, the question says to evaluate f prime of 2x. So, or 2x, f prime of 2 radical 3. So put 2 radical 3 in place of x, which means you're going to put it here, you're going to put it here, you're going to put it there, okay? And you need your unit circle to do this. So pause the video and see if you can evaluate this correctly. Get it all down to one answer, one fraction. Okay, pause the video. All right, welcome back. Hopefully you got the answer of 4 pi plus 3 radical 3 over 12. Now, if you didn't, let's see why here. Okay, you're putting in 2 radical 3 for all of the x's up here. So you want to figure out the inverse tangent of 2 radical 3 over 2 added to 2 times 2 radical 3 over 4 plus 2 radical 3 quantity or whole expression squared. Now, these 2's cancel out. So you're looking at the inverse tangent of just radical 3. Remember what inverse tangent means. It's the angle that has a tangent of radical 3. So getting out your unit circle, remember the inverse tangent is just on this side, all right? I'm going to give you the answer. It's pi over 3, but the reason we know this is because tangent is y divided by x. So if you took the pi over 3, if you took the y and divided it by the x, you would get radical 3, okay? So the y is radical 3 over 2. The x at pi over 3 is 1/2, so I times it by 2 over 1. Remember, when you divide, you times it by the reciprocal. There it is. That's how we get radical 3. So in other words, using pi over 3 for my angle, Dividing out the y and the x makes the tangent of pi over 3 equal to radical 3. So the inverse tangent of radical 3 is pi over 3. Now you're adding right here, you have 4 radical 3, 2 times 2, over 4 plus, be careful on this, this is 4 times 3, 12. Right there, you're squaring the 2, that's a 4. You're squaring radical 3 and timesing it. Radical 3 squared is 3, so 4 times 3, 12. So now we have plus 4 radical 3 over 16. Okay, and we're almost done. Won't 4 and 16 reduce? Makes that a 4, right? How do you add fractions when the denominators are not the same? We simply get a common denominator. So times this by 3 over 3, times this by 4 over 4, and our common denominator will be 12. 4 pi over 12 plus 3 radical 3 over 12. Adding that together in one fraction gives you that right there for your final answer. Before doing our next problem, consider something for a minute. 8 over the absolute value of 8x is going to actually be the same as this right here. Now I'll just prove it to you. Put any number you want in for x. If you have put in positive 4, you're going to have 8 over absolute value of 32. You're going to multiply, and that's going to reduce to 1 over 32. No, 8 over 32. Which reduces to 1/4, but that's the same as 1 over the absolute value of 4. Same answer. Let's put in negative 4. You're going to have 8 over the absolute value of negative 32, which is 8 over 32, which is 1/4 again, which is the same as 1 over the absolute value of the negative 4. Okay? Now, I'm just making a point here. Okay, you got to keep this in mind for the next problem that we're going to do, because we're asked to find the derivative of the inverse secant of 2x, correction. We're asked to find an equation of the line tangent to this graph at these points. These are x and y points. When you do the inverse secant derivative, this is always the absolute value. So that's why when you do this, you keep it like that, okay? Even though you might say, well, the absolute value of x is just going to be x anyway. I know, but when x is negative, it's going to make it different. So it's always absolute value here. Keep that in mind. All right, if you want to try this on your own, pause the video, see if you can answer the question at the top without my help. Okay, let's see what we got here. If you got an answer for the derivative right there, and you got a final answer down there, you did it correctly. Now, if you didn't get all that, let's see why, okay? Let me go back to this page here, because I think I got a little more room. All right. I want to find an equation of the line tangent to this graph. So that means I want to find a slope at a certain point. And that's the point. Well, what formula gives you the slope of something? Isn't it the derivative that gives you the slope? So the slope at the inverse secant of 2x, find the derivative of the inverse secant of 2x. That's the first thing we do. Because again, the derivative is a formula for calculating slope. So let me move this out of the way, and we'll start working on this derivative here. Okay. And here we go. All right. It tells you that you're doing, for the derivative of an inverse secant, 1 over the absolute value of the unknown. The unknown is 2x. All right, like that. Multiplied by the square root of the unknown, 2x squared minus 1. The chain rule again says throw in the derivative of the unknown, so the derivative of the 2x. All right, so that gives us 1 over absolute value of 2x times the square root. This is going to be 4x squared minus 1 times the derivative of 2x is just 2, so it's 2 over 1. And let's do one more step here. You now have 2 over absolute value of 2x times the square root of 4x squared minus 1. And when you multiply across. Now, let's break this up. Isn't it the same as 2 over absolute value of 2x multiplied by 1 over the square root of 4x squared minus 1? That's just making it into 2 separate multiplication problems. But what did we say earlier on the previous screen about something like this? It's the same thing as 1 over absolute value of x, okay? Now again, I know some of you might say, why don't you just take the absolute value away? The reason you don't is because of the definition for the derivative of an inverse secant, okay? So one more step here. That's the answer. The reason you don't is because of the definition of an inverse secant. 1 over absolute value of x times the square root of 4x squared minus 1. And there we go. That's your derivative. Your derivative with an inverse secant will always have an absolute value up there. Okay, let's see if that's the same answer as I have on the next page. Yes, 1 over absolute value of x. 1 over absolute value of x times radical 4x squared minus 1. Okay, right there's your derivative. Now, with that in mind, look what the question was asking. The question was saying, at 1 and pi over 3, find an equation. Okay, at 1 and pi over 3, find an equation of the line that cuts through that x and y point. Well, what does the derivative calculate for you? The slope. So we want f prime of 1, because x is 1. That's going to be 1 over absolute value of 1 times the square root of 4 times 1 squared minus 1, or 1 over absolute value of 1 is 1 times the square root. This is 1 times 4, which is 4 minus 1, which is just 3. So your slope is 1 over radical 3, but remember what I told you, always rationalize answers. You don't have to rationalize the derivative formulas, but answers, radical 3 over 3. That's going to be your slope that goes through 1 pi over 3. So there's our final answer, because we want the equation now, y minus y1. y1 is pi over 3 equals m. m is radical 3 over 3 times x minus x1, which is 1. Okay, try these problems. I gave you those yesterday to do what you could do. See if you can do them all today. All right, have a good night.